Today we're going to begin our unit on applications of integration, but we're going to look at area and volume in Unit 8. So today we're looking at area between two curves. You got to really know what some of these graphs look like to be able to do some of the things that we're going to do. Find the area below this graph right here and above this graph right here from 1 to 2. Okay, well both of these are, well that's a quadratic and that is a cubic. I'm just going to kind of draw like a consensus of this right here. We know that the y-intercept is 3 here, and it's a parabola that goes down. Okay, so it's going something like this. Okay, so this is f of x. All right, this is a cubic. Its y-intercept is actually up here at 5. Okay, and if we were to graph it, it goes something like that. Okay, so that's g of x right there. Okay, and we want from 1 to 2. So we want something right here. We want to know what is that area right there. Well, if I think about this for a second, if I integrate, think integration is the area under a curve. So if I integrate from 1 to 2, and I do the top function minus the bottom function, so f of x minus g of x dx, then I'm going to get the area under that curve. Okay, now I can do this by hand, and you're going to see me, I'm going to do some by calculator, some by hand, just so we can do this a little bit quicker. But here, if I want to do this by hand, I got to be careful. All right, negative x squared plus, and you actually, instead of actually doing right here with the integration, you may want to come out to the side and say negative x squared plus 4x plus 3. And I'm going to minus the negative x cubed plus 7x squared minus 10x plus 5. All right, so if I do a little bit of this math right here, I've got to distribute. Okay, I end up with x cubed. Let's see, negative 8x squared. All right, and then let's see, my x's are going to be 14x, and then minus 2. Okay, so from 1 to 2 of x cubed minus 8x squared plus 14x minus 2, okay, dx. And this isn't too bad to integrate right here. We're going to have x to the 4th over 4 minus 8x cubed over 3 plus 14x squared over 2 minus 2x, and I'm doing this from 1 to 2. All right, so we should know how to do to plug these in and get the values. I'm going to let you do that by yourself. So you're going to plug in 2, plug in 1. Ultimately, the answer comes out to be 49 over 12. I'm more worried with, can you set this up? Okay, so let's look at number 2 here. Find the area between f of x equals negative x squared plus 4x and this quadratic right here. So let's see, what's going on here? So when I look at this one, all right, and if we do want to look at a graph here, and we're doing it from 0 to 1, all right, negative x squared plus 4x, okay, and then x squared minus 6x plus 5. Okay, we're just going to look at a graph instead of actually drawing it. I'm going to say zoom 6 just to get a standard window. And actually what I should probably do is this interval right here. All right, if I do from 0 to 1. So really what's going on from 0 to 1, I have this function on top, and then it switches, and I've got to find where that intersection point is, because what I've got to do is, it really looks like something like this. So here's 0, here's 1, I've got an area right here, and I've got an area right here. Okay, now this is f of x, and then this is g of x. Okay, so anytime I do the area, I want to do the one on top minus the one on bottom, but the problem is I got to know where that intersection is. Second trace, 5 for intersect, 1, 2, 3. Okay, and that intersection is at x equals 0.56. I'm going to say 35. I'm going to give myself one more place. All right, so what that means is I'm going to do the integral from 0 to 0.5635 of when g of x is on top minus f of x. Okay, dx. And then I have to add it. Now I can do from this point, that x value, 0.5635, all the way to 1, when f of x is on top. So f of x minus g of x. Now that's going to be a lot to do by hand. So let's go ahead and actually just plug this into our calculator. What I'm going to do is in y equals, and I think I already had it there, we already have f of x here and g of x here. So what I can do is go back to my home screen, okay, and I'm going to move it over here so we can see everything. I'm going to say alpha y equals, and I'm going to integrate from 0 to 0.5635, okay. G of x was the second one, so I'm going to say alpha y equals and go all the way to here, and it's y2 minus y1, and actually, okay, dx. All right, and then I want to add, and I'm going to do the integral of 0.5635, all right, all the way to 1, of f of x. F of x is in y1. Minus y2. And here we go. We get our answer. And our answer is 2.03, we'll just say 16. Okay, at least keep 3 decimal places. I'm more worried about, can you set that up? Yes, it would take a long time to solve by hand. And just be careful on that. All right. Okay. So moving right along, let's go to number 3. You'll notice number 3, we see this right here. Now, I want you to notice this time we don't have an interval. Okay. All we want is to find the area between f of x and g of x. If I actually expand the graph out, it looks something like this. We really just want this area that's in between here, okay, that I'm coloring in right now. Okay, well, what's on top? Well, here, this is the parabola that goes down, so that's f of x, and the one on bottom is going to be g of x. Now, I already know that one intersection point. I need to find the other intersection. If you need to recall both of them, we say second trace, 5 for intersect. So the one intersection's at 0.5635, and then the other second trace, 5 for intersect, 1, 2, 3. Because they didn't give us the bounds, we have to come up with the bounds ourselves. All right, so there's going to be our bounds. So we are going to go from 0.5635 to 4.4365. All right, and remember what was on top. F of x was on top minus g of x. All right, now I already have these in my calculator. Okay, I'm going to go alpha y equals. All right, I want to integrate. Okay, and I put 0.5635, and then I put 4.4365. All right, f of x was y1, so alpha y equals, if I scroll over to the left, it gets there quicker, minus y2. Don't forget to put the x in before you press enter. And here we go. We get our answer to be approximately 19.3649. All right, moving right along. Find the area bounded by, so I've got two different things right here. Okay, so this one's not too bad. This is the function, okay, 0, 0, 2, let's see, 1 is going to be 1 squared, 2 is 4, okay, and so forth. So it goes something like that. Now this one's a little different. 0 is 0, 0, okay, 1 takes us back to 0. All right, at 2, let's see, that's 16 minus 4, so that takes us all the way up to 12, which would be right here. So it's doing something, and I'll let you know, it goes up like this, and it does something like this. All right, and eventually goes back up. Okay, so it's intersecting somewhere right in here. We want the area that's bounded between these two. Okay, well notice which one's on top. This is going to be x squared. Okay, and which one's on bottom. The problem is I need to know where it intersects right in here. We know it intersects right here at 0, so the bound's going to start at 0. But when I take my calculator, all right, let's go plug our functions in. X to the 4th. And I could set these equal to one, and actually I'm going to do that. Instead of doing it on my calculator, you can set these equal to one another. All right, you get x to the 4th equals 2x squared. Or actually, if I move this over, it's minus 2x squared equals 0. If I factor it, okay, this one, x equals 0, but here when I say x squared minus 2 equal to 0, I get x squared equals 2. So it's plus or minus, it must be the positive square root of 2. Okay, so I'm going all the way to the square root of 2 right here. All right, and I'm doing this one right here, the x squared, minus this one. Now when I do that one, I've got to put it in parentheses because I got to distribute that negative sign. All right, when I distribute the negative sign, it makes 2x squared minus x to the 4th. All right, and I can do that by hand pretty quickly. Let me erase my graph here so I have a little more room on. All right, so here this is going to be 2x to the 3rd over 3 minus x to the 5th over 5, and I'm doing it from 0 to square root of 2. All right, when I plug in square root of 2, it's 2 square roots of 2 cubed over 3 minus the square root of 2 to the 5th over 5. And then if I plug in 0, it's not going to make any difference because that's just going to be 0. If you do want to clean it up, you can say times 2 to the 3 halves, 2 to the 5 halves, and then if you actually look at this, this is to the 1st, so if I add that together, that's actually 2 to the 5 halves. And you can really just leave the answer like that if you want. You can make it go down. You can get a common denominator and things like that, but I'm just going to leave my answer like this and not be so complicated. All right, number 5. All right, I want to look at these two graphs, and I want to find the area from 0 to pi. All right, well, let's look at these graphs right here. Okay, sine x, and make sure you're in radians, cosine x, okay, and then sine x. Okay, and since I just want it from 0 to pi, I'm going to put that in as my x bounds and just say graph. I don't really know what my y should be right at the moment. Although we know like sine only goes up to 1. All right, so if you actually want to take your window and do, say, let's see, negative 2 to 2, that might actually look a little better. Or you can say zoom fit. Okay, and if you notice, I really just want this area right here. So I need to find where it crosses right there, and I need to find where it crosses right here, where they intersect. Second trace, 5 for intersect. All right, and you can set them equal if you want to set it equal by hand. Actually, I don't have to find the intersection. It gave me the intervals, so I'm doing 0 to pi. Okay, I just need to know what's on top, and what's on top is the sine x. So I'm doing sine x minus sine x cosine x. If you do this one by hand, you might want to split it up. Okay, here, when I integrate that, that is negative cosine from 0 to pi. Okay, now here, when I integrate that, I can make like u, say, sine x. Okay, du equals cosine x dx. So this is actually going to be sine squared x over 2 from 0 to pi. All right, so here, negative cosine pi minus negative cosine 0. Okay, this is minus all of this, so I got to put it in brackets or parentheses. Okay, sine squared pi over 2 minus sine squared pi over, or I mean 0 over 2. Well, I'm lucky on this. Both of these equal 0. Okay, so those go away. However, cosine of pi is negative 1, so that makes a positive 1 right there. Cosine of 0 is 1, so the final answer is 2. So the area from 0 to pi on that curve is 2. Now, sometimes it's easier, if you notice everything we've done in terms of x, sometimes it's easier to find area using horizontal slices, integration with respect to y, and using the y-axis as the bounds. Okay, so when we talk about this, we would have it with respect to y, and we would have y's in here. And I like to tell students this: if I have y's here, then these bounds are coming from my y-axis. If I have x's here, these bounds are coming from my x-axis. Now, when I do the x's, I subtract the top from the bottom. If I'm doing my y's, I'm subtracting from my right to my left. Okay, and you're going to see us do that in just a second. So this is going to be the right curve, and this is the left curve instead of it being top and bottom. All right, so let's look at this. We want the area between, and you'll notice that these are all x equals. Could I change it to y equals? Yes. However, it already gives me the bounds on the y-axis from 0 to 3. All right, so, and if you do want to think of this for a second when you're graphing, all right, it's a slope of 1 and it's negative 6 down here. So what's actually happening? 1, 2, 3, 4. Okay. We've got this line that looks like this. Now, this one is a sideways parabola. This is going to be 2, I think it's like 2, 4. Or 2, and think about this. If I put in, and what you really want is 3 squared, it's at 9. Okay, when y is 3, this is 9. All right, so this is going something like this. And I only want it from a 0 to 3, so I want this area right here. All right, so I'm doing it 0 to 3. Now, I'm going left to right because this is y's. Okay, so left is this one right here. Okay, minus y squared. Okay, this one's not a bad one to integrate, because I'm going to end up with y squared over 2 plus 6y minus y cubed over 3, and I'm doing it from 0 to 3. 0 is not going to have any effect on it, but 3 squared is 9. Okay, 6 times 3 is 18. That's 27 over 3. So far, it's not too bad. That's if you want to change it to 4.5 plus 18 minus 9. So we know that's 9. 4.5 plus 9 gives us 13.5 as the final area. Okay, let's look at number 7. If you notice, again, this is in terms of x equals, so I'm going to have to do the bounds on the y-axis. Now, my problem is I don't actually know the bounds. Now, I know that this one line goes like this. It's just y equals x. All right, this one, if I plug in, say, 0, I get 0. If I plug in 1, I get -3. Okay, if I plug in 2, all right, so let's think about that for a second. If I plug in 2, that's going to be 4. Minus 8 is -4. All right, if I plug in, and I might want to go this way too. Okay, if I plug in, say, -1, -1 would be +1 minus 4. All right. Whoops. And that would be 5, actually. All right, and so forth. And so it's this U shape. It's kind of funny. All right, it's this U shape coming all the way. Like it's going to go something like this. Now, what's actually happening? All right, and I know I didn't cross it at the same thing. What you could do is set these equal, y squared minus 4y equal to y. This is the easiest way to find it, and you factor it. Here I get y equals 0, so they cross at y equals 0. All right, and so I don't really have the intersection correct there. All right, and then they also cross at y equals 5, which would actually be right here. All right, and I want this area right there, so I don't need that. Okay, so I'm doing it from 0 to 5. Now, because it's going to have y's in it, it's going to go left to right. So I see the line first, minus, and I got to put parentheses, y squared minus 4y. Don't forget your dy. Now, for subtraction, I've got to change my signs. So this is going to be 0 to 5 of negative y squared plus 5y. All right, so if I integrate it, it's negative y cubed over 3 plus 5y squared over 2, and I'm doing it from 0 to 5. I'll let you plug that in. 0 is not going to have any effect, but 5 is. The final answer can come out to be 125 over 6, and that's when you get a common denominator. All right, let's look at number 8. Okay, the area between, all right, x equals 0 is the line, is just the y-axis, and y cubed minus y. Well, if I actually graph this, this actually does something like this. These hit at 1 and -1, and I've got this area right here and this area right here. I have two different things. I have an area from 0 to 1, okay, where this line is first, 0 minus the y cubed minus y. All right, and then I have another area from, we'll say, -1 to 0, and where this part, y cubed minus y, comes first. All right, and I can say minus 0, but it's not going to have any effect on it. Here I would have to distribute. Okay, and then we would do the math on it, and I'll let you go ahead and do the math. I'm going to give you the final answer. Once I add both of these together, these integrals together, you should get 1/2. All right, and then number 9, the area between, this should be y squared plus 1 and x equals 0, and then y is -1 and y is 2. So y is -1 is right here, y is 2 is right here. And this is y squared. Okay, so here if I plug in 0, I get 1. So when y is 0, x is 1. All right, and then, so it's a little backwards. All right, if I plug in y equals 1, all right, when y equals 1, then x is 2. So x is 2 when y is 1. All right, what about if I plug in y is 2, which is actually on this line? That's going to give us 5. All right, and then if I plug in -1 squared, it's going to go back to 2. All right, so this is going something like this. And then x equals 0 is this line right here. So we want to know the area between this line and this line, and then these other two lines. All right, now since this is in y's, I'm going to use the bounds on the y-axis from -1 to 2. All right, and notice the quadratic comes first, and then the line x equals 0. So I'm going to do y squared plus 1 minus the 0. Now again, I don't need 0, and now I can just integrate it. I'll let you integrate that to get an answer, and the final answer should come out to be 6. I think you can do the math on it. Be careful, sometimes these are going to be with and without a calculator. With a calculator, I can just throw this in pretty quickly. Without a calculator, you are going to have to do some math, so be careful and practice that.